Bismillahirrahmanirrahim. Assalamu-Alaikum Warahmatullahi. My dear students, once again I am with you in a new lecture from chemistry first year, chapter number 6, chemical equilibrium. And this is the third lecture from the same chapter that we are going through today. Before starting today's lecture, I must recall your memories and want to refresh your minds that what we did in our previous lecture, lecture number 2 from the same chapter. We discussed law of mass action or law of equilibrium there, and when we ended the lecture we got the equilibrium constant expression, in which we got the value of Kc, the equilibrium constant Kc, which was mathematically equal to the concentration of products upon concentration of reactants. This was the general expression which we got in the end of that topic. Kc equals to products upon reactants. My dear students, in this particular expression Kc, which is called the equilibrium constant, the letter C is the general representation of concentration of the reactants and products. And when we talk about the molar concentrations of reactants and products, it means that the reaction must have been proceeded in the solution form or in liquid state. Now, if I talk about a chemical reaction which is entirely in the gaseous state, then the equilibrium constant used there will not be Kc, rather it will be Kp, because the pressure, partial pressure of the gases are directly proportional to the concentration. So if I talk about a general reaction in which are made to react A gas with B gas, and as a result of that I got C gas and D gas. Now by applying law of mass action, I will write the equilibrium constant expression as Kp equals to the partial pressure of gas C into the partial pressure of gas D upon partial pressure of gas A into the partial pressure of gas B. Now here Kp is the equilibrium constant, while Pa, Pb, Pc and Pd are the partial pressures of the gases A, B, C and D respectively. So dear students, you must note here that for any chemical reaction which is taking place in the gaseous state, entirely gaseous phase, we can use the equilibrium constant Kp, where the letter P represents the partial pressure of those gases, while if the same reaction is carried out in the entire liquid phase, the equilibrium constant used will be Kc rather than Kp, where the letter C represents the concentrations of the reactants and products. In both the ways, if you look into the expression, general expression, the equilibrium constant, whether it is Kc or Kp, it is mathematically equal to the ratio of the partial pressures of the products upon partial pressures of reactants, or ratio of the molar concentration of the products upon molar concentration of reactants. So I must say that for a reaction which we proceed in both the conditions, in gaseous phase and liquid phase, we can find out the value of Kc as well as Kp for the same reaction. Now a very important topic which I want to discuss with you people today is the relationship between Kc and Kp. This is a very important topic and it often comes in your board exams as well. So it's a very simple and easy topic, smaller one. We are discussing it today. Relationship between Kc and Kp. Question often comes in your board exams as what do you understand or what do you mean by Kc and Kp, and discuss or describe their relationship. This is the question which often comes in your board exams. So if you want to discuss the relationship between Kc and Kp, as I already told you that for the same chemical reaction we can find out the value of Kc as well as Kp depending upon the nature of reactant and products. If the reactant and products are used in the physical state of liquid, we can find out the value of Kc for that, and if we use the same reaction in the gaseous phase, we can find out the value of Kp for the same reaction. So coming back to my topic, the relationship between Kc and Kp, there are three relationships. Between Kc and Kp. The first one is Kc equals to Kp. Always remember, my dear students, that whenever we are dealing with a reaction in which the number of moles or volume on both the sides of the reaction are taking equal, the value of Kc and Kp must be equal to each other. Whenever the volume, or I must say number of moles whenever the volume or number of moles is equal on both the sides means reactant side and product side, the value of Kc must be equal to that of Kp. Here, if I talk about an example, H2 plus I2 equals to 2HI. If you look into the balance equation here, one volume plus one volume means total volume on the reactant side taken is 2, and total volume formed on the product side is also 2. So volume on both the sides is kept equal. So in such a case, Kc and Kp must be equal to each other. This is the first relationship between Kc and Kp. Now, proceeding further, if I talk about the second relationship, says Kc becomes greater than Kp, or it shall be written as Kp becomes less than Kc. Both means same. Now this is the condition, my dear students, when the volume or number of moles on the reactant side becomes greater than that on the product side. When the volume or number of moles is greater on the reactant side as compared to that on the product side, the value of Kc will be greater than that of Kp. Now in this case, if I quote an example, two moles of sulfur dioxide gas are oxidized or burnt with 1 mole of oxygen gas to give 2 moles of sulfur trioxide gas. Now if you look into the volume of the gases used here, 2 volumes of SO2 combined with 1 volume of O2 means total volume on the reactant side is 3, while the volume produced on the product side is 2 only. So in such a case, when volume on the reactant side is greater than product side, Kc will always be greater than Kp, or we can say Kp will always be less than Kc. This is the second relationship between Kc and Kp. Proceeding further, the third case. Now I must say, if Kc becomes less than Kp, or you can say Kp becomes greater than Kc. Now the condition in this case will be, whenever the volume or number of moles on the reactant side is less than that on the product side, the value of Kc will be less than that of Kp. Now the particular example in this case I am writing on the board as two moles of ammonia gas are dissociated to give 1 mole of nitrogen gas along with 3 moles of hydrogen gas. Now comparing the volumes on the reactant and product side, total volume used on the reactant side is 2, while the volume produced on the product side is 1 plus 3. So total volume produced on the product side is 4 volume. So in such a case, Kp will always be greater than Kc, or you must say Kc will be lesser than Kp. So this was a relatively smaller but easier topic, relationship between Kc and Kp, which we discussed today. Now one thing I must tell you, in the previous years I do remember that an MCQ comes from this topic in such a way that the reaction of ammonia was given and its Kc value was also given, and you are asked to calculate the value of Kp for the reaction. So if a question comes, there is no such example given in our syntax board syllabus, but such type of examples are rather being given in the Punjab or Federal Board books. So I must discuss here, if a reaction comes in your exam, any reaction, and the value of Kc for the reaction will be given to you, and you will be asked to calculate the value of Kp for that particular reaction. The relationship which we use for the calculation of Kp for the reaction using the value of Kc given is Kp is equal to Kc into RT power delta N. Dear students, this is the formula, this is the relationship by which you can calculate the value of Kp for a reversible reaction using the value of Kc given in the question. Now Kc will be given to you. R is the universal gas constant, which is 0.0821 atmosphere into dm cube into mole inverse into Kelvin inverse. You must remember that. T is the temperature in the Kelvin scale, and delta N is the difference of moles on both the sides of the reaction. For example, if I consider this particular reaction, number of moles on the reactant side is just 2, number of moles on the product side is 4. So we can say that delta N must be 4 minus 2, 4 minus 2 must be 2. So delta N is the change in number of moles or difference of number of moles. You can calculate by looking into the balancing equation. R is the universal gas constant, T is the absolute temperature, Kc will be given to you in the question. You will be required to find out the value of Kp. So this is the formula by which you can find out the value of Kp using the value of Kc in the given equation or reaction. So today's lecture is enough. Inshallah, we will be discussing further things onward in this chapter in our upcoming video lectures. Thank you very much. Allah Hafiz. Assalamu-Alaikum Warahmatullahi Wabarakatuh.